Okay, guys, so we need a calculator to find our t-statistics. And when I calculated this, it was negative 1.24. And the reason it's a negative is because your mean is smaller than the population mean that was suggested, right? So how do we use alpha? Because we don't just compare alpha with the t-statistics, because alpha value actually indicates the area, but t-statistics indicates a value, right? So what you do is that you use inverse t using this area. But what you need to be careful of is looking at this sign right here. So this, when you have an alternative hypothesis not equal to, sometimes we call this two-tail test, meaning that the area is divided into two areas, the two tails, okay? So these have to add up to 0.05, meaning that this area is 0.025. So you're going to use inverse t, area will be 0.025, your degrees of freedom will be 10 minus 1, which is 9. So then you get a value of negative 2.26. So you compare this value with your t-statistics. And you can tell the t-statistics is greater than the alpha, right? Meaning that here it's negative 2.26, then my value, the t, is here. So it's not part of the area, meaning that we fail to reject the null hypothesis. So that is our conclusion. We fail to reject the null hypothesis because the t-statistics, negative 1.24, is greater than negative 2.26, which is the alpha, which is the value that corresponds with the alpha value here. What that means is that we do not have enough evidence to support the alternative hypothesis. So that is another line that you will write, but let's continue with number 6, and then I'll write more formally here. All right, so a mail carrier claims that the average number of pieces of mail received daily by households in a certain neighborhood is 7. I'm just going to type because it's a lot more to write in pen. So first thing first, we need to define the mu. So the mu is true average number of pieces of mail received daily by households in this neighborhood. Okay. Then the null hypothesis, which is the H0, will be mu is equal to 7, right? And the alternative hypothesis is that mu is not equal to 0. That's my not equal to 7, right? Because it doesn't say that it's greater or less than. So that's my setup. And then the alpha that was given was 0.05 for the part A, and then the second one is 0.01. Some other important information is that n, the sample size is 15, the average, so x bar is 6.5, and the standard deviation is 0.8. Okay, so these are all from the question, and these are all the information that I need in order to solve this question. So usually I write it in this on the side so that it's easy to see. So then we need to find t again because my sample size is small. And so t is equal to 6.5 minus 7 divided by 0.8 divided by square root of 15, right? The standard error. So we have to calculate that on the calculator first. If I do that, I get, I don't know if this is correct. It's a negative 2.42. All right, so we need to compare that with the value that will give me area of the two-tailed test of 0.05, meaning that this has to be 0.025 in the area. So use inverse t, but now the degrees of freedom for this question is 14 because my sample size was 15. So then this is negative 2.14. So then you can see that this is greater, right? The value for the alpha is greater than the t statistics. So the conclusion we have is we reject the null hypothesis. We reject the null hypothesis since the t statistics negative 2.42 is smaller than negative 2.4. The t statistic corresponds with the alpha value. Therefore, we have enough evidence to claim that the alternative hypothesis is true. Okay, so that's what we write as a conclusion. This is part A. I don't have a space. My computer is very slow, so I'll put it right here. Part B, you don't have to do all that stuff again. Only thing you need to do is actually finding inverse t for new alpha, which is a 0.01. So that means that this area, these two area will add up to 0.01. That means the one area will be 0.005. So you want to do inverse t of 0.005 comma 14. So you can tell that it's going to be a smaller value than before. 0.05. So that gives me negative 2.98. Alright, so if the significance level changes to 0.01, we actually fail to reject the null hypothesis. So we write, we fail to reject the null hypothesis since the t statistic negative 2.42 is greater than negative 2.98. T statistic that corresponds with the alpha value 0.1. That means we do not have enough evidence to support the alternative hypothesis. That's it. That's it for part D. And actually, that's it for this lesson. So you have to be able to first define the variable you're working on, write the alternative and null hypothesis, carry out and find the t statistics, carry out the inverse t function to find the alpha, the t value for the alpha, and then compare the two t statistics. And if your t value is greater than the alpha t value, then you fail to reject the null hypothesis. If your t statistic is smaller than it's basically kind of like a critical t value, then you reject the null hypothesis. I hope this makes sense. If not, ask me some questions before you start your work for tomorrow. And yeah, maybe we'll have a fun Zoom class on Thursday if you guys are not going crazy and having some kind of closure for this year. Yeah, that's it for today. Bye.